Hello, welcome back. We're continuing where we left off last night. Still trying to get Natalie to be able to compile the Ruby parser library so that we can start parsing Ruby ourselves instead of doing that in Matz's Ruby interpreter, MRI. We want to do that in our own runtime, and then we can do all kinds of fun stuff at runtime and more dynamic programming and stuff like that. So where I left off last night was super was not working, and I ended up making a failing test case for that super test, and let's just enable that and see it fail. Test, super test. So here's the same error. It's there is no arg count and args in in the begin block because of the way I wrote it, because I'm kind of a dummy. But we can actually show this here if I do Natalie. This is gonna be kind of involved. Foo. Let's say that returns foo. You know, it might be easier if I just do wat.rb class foo def foo returns foo. I do class bar foo, and it has a foo, and it calls super. And if I do bar.new.foo, then we get the foo string, right? And but if I put this inside of a begin block with a rescue, like so, then Natalie does not like that. Natalie blows up. And I can show you what the C++ looks like when that happens. Right about here is the begin function. That the begin block in Ruby turns into a begin function in C++, and the super turns into this big old long thing where we call the method on the superclass, which that is not actually correct, but I'm not worried about that right now. On the superclass, we find the current method name, and then we pass in the arg count, args, and the block, which that is also wrong. So there's lots of things wrong here. But what we're working on right now is the fact that this arg count, args, and args, these two things are not available because of this function signature here. So I believe we're just going to pass this stuff in to every begin function and pass it along, and that hopefully will fix the issue. The call begin function is pretty simple. All it does is creates a new environment and then calls the function. But we want to change this a little bit. Let's just do this. This actually isn't even used. I saw this the other day. I think that's not even used. So we'll say this is a begin function pointer, and we're gonna I'm gonna make this a little easier to mess around with. So that's the function signature of a begin function, but it has a size t after that, and it has an array of arguments and a block pointer. So now we can do this. We can do begin function pointer begin function. Oh. I just realized that says block function, but I think it's begin function. Why did I call it that? I don't know. Begin function. Function, and then we're going to pass in the size t arg count, value, args, and block, and we're just going to pass them along to here. This is a little bit weird, I guess. I don't even know if this is the right way to do this, but I think it'll work. Let's copy this signature over to here. I'm going to delete these names because it's something I've started doing more and more of, but haven't fully finished in this file. but I'll go ahead and do it here. So that's the function pointer, that's that. So now we just need to find all the places this is actually used, which appears to only be one place, so that's nice. So we're going to pass in the arg count, the args, and the block. Okay. And that's not going to be enough. There's something else I got to do. I can't remember where else that is. Okay, oh yeah, because we're still creating the begin function with only 2 parameters. So that's done in pass 4 of our compiler. And this is kind of a convoluted mess. I won't bother explaining it. But basically we're just changing this from a 2 argument function to a full 6 argument function, where it takes the environment, self, arg count, args, and block. Which just makes me realize, kind of makes me realize this method function pointer, is that the same exact thing? It is. So I don't think I need this begin function pointer. I can just use the method function pointer. It's the same. And that's going to work. Let's just see. Let's just see if this works. If not, I can put it back. Come on. If I can type begin function, method function pointer, why are you still red? Unknown type name. So because I'm only declaring that in the forward header, is that even good? Okay, well, let's try. Let's give it a try. Okay, that's good, promising thing there. And let's run our super test. That passes. Oh, cool. Okay. Let's just go over this. So that was something that was unused. I believe I should run the whole test suite just to make sure. Yep. Passing the more arguments, building the function with more arguments. It's just some busy work and looks good. So let's just run some tests here. And while that's running, let's wait. I'm not sure how far I'm going to go tonight. Not feeling too well, but just thought I'd get at least that thing done. So let's run this again. This is slow. This is really slow. I don't really know how much of this time is spent. Well, I guess probably a lot of it's spent in Ruby, MRI Ruby. So I don't know how much time I want to spend on it because we're actually moving our parser and compiler out of Ruby eventually, out of MRI Ruby. Natalie will eventually be able to compile that, and so then we'll have a whole new set of problems, and it'll probably be even slower than this, but hope not. Maybe not. And my lighting is really harsh. I got to work on that. I can't even turn on that light. Oh, there we go. I can't turn on that light because it just messes up the video really badly. Test suite is running. This is taking forever. Probably doesn't help that this test suite is running over here and using up all my threads. Waiting. Probably wasn't advisable to run 2 big things at once. Okay, I'm just gonna stop that. See if this will actually do its thing. Oh, there it does. Okay. Ooh, got a whole nother set of problems. Case value 210 may be used uninitialized in this function. Whoa, that's totally new. Okay, that looks like fun. Let's work on that. 2765. 2760. Oops. 2765. Come on. What is case value? Whoa. It's just interesting. It's just a value that's never initialized. Well, thank you, errors. Thank you, compiler errors. So is this like, oh, we should go look at the source code. Okay, so 279, 279, 279, 279, 279, 279. Ruby Lexer RB 279. I actually did need that tab. 279 Ruby Lexer. 279. That's here. Case when, yada, 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 yada. There's a bunch of wins. Fascinating. Okay. Not sure if that helps me or not. Let's go back to here. Nope. Where was I? That's here. This case value if call result is truthy. So is it reusing the same name for something? Text end with RI, text end with yada yada yada. Text. Text matched. Okay, let's go back a little higher. So this is essentially the text variable. Oh yeah, right there, of course. We assign it to this text variable. And then we create this case value, which is going to be the result of the case statement, the result of the whole thing, which in this case is not actually used because we're doing a return, but every case statement has a value. It's an expression. So that would be the final result of the case. But what I don't know is why it's being passed as arguments to something. The result is being passed. It's weird. Maybe if I stare at this some more. So this one line of code turns into, I believe, all of this. Yeah. Is that right? Result, send result. Yeah. So this one line of code turns into all this. This one line of code here turns into this. But why? Oh. Oh. I think I know what the problem is. So when I built the support for case statements, I did this. Foo. When, let's just say, it's X. When it's one, did I do it wrong? Oh, case, there we go. When it's one, then, print one or something. When it's 2 through 3, then it's 2 or 3. so on and so forth. And the way this works behind the scenes is it takes the first one and goes, is 1 triple equal x? I think that's how it works. And then the next one it does, is 2 dot dot 3 triple equals x? Which, let me just verify. So if I do 2 dot dot 3, it's 3 value for range. Yes. So that's what it does behind the scenes. And so what I didn't account for, obviously, was if they're not comparing it to anything. In this case, the case has no value to compare it to. So I need to build a case, case when test. Matches on equality, returns nil if no match. I don't have anything that does that. Yeah, okay, so we'll just do this. It matches when there is, does not require a value to match. So if I do result equals case when true, yep. When false, nope. Then result should equal yep. And Natalie test, Natalie case when test. Yeah, same error. Okay, cool, making progress. Making some progress. Now we get to go figure out where in the world is Carmen Sandiego. Where in the world is our case when stuff built? Process case, it's right here. It's not a lot of code. I just gotta remember how it works. Okay, so this is the result. We store that here, and that's variable. And then for each when, we do this stuff, but I need to try something. So what if you have case 1 when true end? What do you get? You get nil. If you have case when true end, you get that. Okay. Ooh. Matchers. That's each when. Value. That's this. So what is value? Finale AST case when 1 end. What does that look like? And then what if I put a value here, like 2? Okay, so it's just nil. When it's nil, we want to handle things differently. Say, oh, case value. Okay, so we want to say, I'm just going to do this the dumbest way possible first, value. So if there's a value, then we're going to do all this. Otherwise, we're going to do something similar but different. And then I'm going to see if there's any similarities. But I don't want to be trying to shoehorn this totally different logic into this top bit of code. I've found that that's pretty painful. So value name, if is truthy, we basically just want to, we don't want to do a send, we just want to say, is it truthy? We don't need that. And I think we can just return the cond. Maybe. That works. Well, that's not too bad. Now, how many similarities are there between this and this? Quite a lot, actually. But I don't know. I think it would just be more confusing. So let's just leave it like this for now. So case something when matcher end. Do I even want that? Matching against a value. Just a glorified if else if. That's basically what it is. Yeah. Just make sure all the tests pass. I need to sit back and take a drink. Anyway. I mean, this didn't break anything, so it's okay. So let's commit what we did before, which I've already forgotten what we did before. This was fixing super inside a begin rescue, and this code is fix. Did I say fixing? Hold on. Fix super. I don't know why I did that. That was weird. Okay. Fix case when with no value to match. Okay. Cool. Push that. Back over here. Well, let's run this and see what the next error is. Holy moly, that took forever. Undefined method required for me. Okay. I'll fix that. 380. Unless defined. Yeah, you can't have conditional requires in Natalie yet, so I'm going to say this is probably usually false, and this is usually true. How do you close tabs? They're D. I've been trying to learn how to use Qt browser, and it's been kind of fun. Find method 0 for 0. Ooh, well, that's an easy one. Why don't we just do that? Find method 0 for 0. You know, I thought we had done that before, but oops, wrong tab. Did your test 0? Oh, fine. Describe 0. Specify do 0.0 should equal true, 1.0 should equal false, and -1. Integer CPP. You know, maybe we did it on float. I just want to copy this code. Basically, I want it to look exactly the same. There we go. Is 0. Ha! Right there. I just don't have a binding for it. Yeah. Well, Awesome. Well, that's a super easy one. Let's say integer 0, integer value is 0, no args, all that. Run make. Test, Nelly integer test. I didn't see the test fail, but I'm pretty sure I know exactly how to fix that. So let's do add integer 0, push, and I think I'm going to call it a night. I am going to run this one more time and just see what the next error is, and maybe it'll be something simple, but we'll do it next time. We'll do it next time. Saturday is the day. Maybe I'll do a longer session on Saturday. And find method map for an empty hash. And find method map for hash. Well, that should be interesting. Yeah, cool. Man, I'm tempted to do it right now, but I'm pooped. So I think we'll call it good for tonight. Thanks for watching. I'm going to keep working on trying to get the Ruby parser gem. Well, it won't be we're not really using it as a gem, but the Ruby parser library to get it to compile with Natalie. And I'm just excited about the possibilities of being able to get to the AST, the parsed AST from inside of C++, and do something amazing with it. So yeah, thanks for hanging out with me tonight, and I guess I'll see you next time. Bye.